A nice introduction, Peter. Yes, so you already saw today a talk about new features in LS-DYNA R13. So the purpose of my talk would be to focus on crash applications. Even if I have to apologize, there are a few slides that you already saw this morning, but also quite a few others. So the release R13 was published a few weeks ago, and this presentation will be about the major changes since the last release. The slides were put together by all developers from ANSYS LST and Dynamore. The topics I will go through with the focus on crash-relevant applications are these ones, so contact, elements, materials, connections, batteries, airbags, sensors, performance, and others. So let's start with the first one, which is contact. For the soft equal to contact, there is a new option. And the reason we added this new option was that we experienced in situations where tetrahedral elements were involved, that the penetrations were too large or the contact forces were too low, which, for instance, can be seen in this picture. So we have these situations where we only have hex and shell elements involved, and these two bring the following contact forces versus penetration, and all the ones with the tetrahedral elements involved have way too low contact forces here. So we introduced this new parameter TETFAC, which is a scale factor for the computed volume of TETs for the mass calculation, and with a factor of 3 to 5, you get a much better agreement with the other contact situations here. So that's on star contact card, optional cards, something. Next, this is what you already saw this morning. It's a new solid element formulation, type 62. It's a fully integrated 8-node hexahedral element, which is somehow an alternative to the existing element formulations -1, -2, I would say. And the goal with this implementation was also to have a better way to avoid shear and volumetric locking, to have a fast, accurate, and robust element. And in this movie, you can see, as this morning, the new element formulation gives good results for skewed as well as non-skewed as meshes. And this is the corresponding displacements. Then, for the isogeometric analysis, as Jason already mentioned this morning, there are numerous efforts or are done to fully incorporate this new method in vehicle crash simulation. So that's the goal, and it will take some time, but the steps are pretty big, especially towards R13 and probably in the upcoming versions as well. So just a few new enhancements. There's a new IGA keyword family. The mechanical coupling of shell patches to T-joints is done with this tight edge-to-edge keyword. SPR3 is supported, as well as rigid walls. We have the boundary conditions, the Dirichlet and the nodal boundary conditions with these keywords implemented. And I would like to point out that there is a special session about IGA this afternoon, C4, where you will learn way more about this, all these new features and enhancements, and the background of this still new method. And Jason already showed that a very nice thing is the idea to take your crash model and just replace a few, maybe most interesting parts, and replace them by IGA, and then gain some experience with that, and compare with the old approach and so on. So I would like to point out to that other session for that topic. So here another minor new feature which can be found on the section shell, and that is the new option called thick scale. With that, you can scale, as the name says, the shell thickness for all elements of a section, including those with thickness specified using element shell thickness. So that means you have a non-uniform distribution of the thickness, but you can uniformly scale that. So, for instance, that could be interesting for sensitivity studies or structural optimization. So if you have a part in your crash analysis where you get results from a forming simulation before, then you might have such a distribution of the thickness, and with the scale factor, you can just increase or lower this thickness uniformly in this part. Also, Jason showed this add inelasticity keyword that is already available since R12 already, but a lot of new features were added in the R13 as listed here. So we have some orthotropic field overlay for thermal expansion and failure. There's temperature shifts in hyperviscoelasticity. We have some new hyperviscoelastic laws, support of higher order tetrahedron elements, or Norton-Bailey creep law, as shown in this example, for instance. So as Jason mentioned, the idea of this whole approach is to add a missing material behavior to an existing material. So that could be these ones, but all other standard material models, which we have 300 of them, you can add that. And there's also a paper presented I think that's tomorrow morning in session D3 about where you will probably learn more about it. Then we have for the DM, that's our damage initiation and evolution model, we have a new possibility to use this so-called FLD or MSFLD criterion also for solid elements. So initially it was implemented only for shells because it has some assumptions like plane stress in that criterion. But now that was extended to be available for solid elements as well. You will find some mesh restrictions you have to take care about, for instance, about the element, the node numbering scheme and so on, and a few others, and that's described in the manual. And if you do that, then you will see in a comparison, is there a movie? No. Okay. In a comparison to shell elements, you can see that you get a pretty good agreement, and it's not only available for solid elements now, but also for thick shells. Then we have added some nonlinear viscoelasticity to a plasticity model. We started to think about adding that to MET 24, but we used MET 123, which is pretty much the same as MET 24. And there we added this non-viscoelastic model. So it's based on von Mises viscous plasticity. And now you can define a Young's modulus as a function of an average strain rate, as shown in this picture here. And also you define a constant decay coefficient to represent the viscosity, so this damper here. And that could be interesting for applications where you have polymers involved, where not only the plastic behavior is strain rate dependent, but also the elastic portion here. And it's a pretty simple approach, so calibration is not that difficult, and you could at least increase somehow the accuracy for materials like that. Then we have a new material model for composites, MET 249 crash. So it's for reinforced thermoplastics. And it features a phenomenological approach for softening due to damage and failure. So there's the possibility to have some tabular input data defining damage parameters, which gives much flexibility. Then we have anisotropic fiber formulation there, where fiber stretch and compression damages fiber and matrix. The fibers can reorient and so on. So that's a material model that's really available or for applications such as fabrics, woven and non-crimped fabrics, and for total damage of the material, so element erosion, the matrix as well as the fibers have to fail, as shown here. So then a few minor material model enhancements listed here. For instance, there is a new strain rate term in the Matt Johnson Cook Matt 15. So you have two or three new parameters there, and this is an approach by Cook. Paper by Cook, and it says that you get better flow stress prediction along the full strain rate range as shown here. Then there's a new strain rate filtering option added to two material models. That's the Matt Spotwell Daimler and the Matt 124. So there you can now have an exponential moving average for the strain rate, which should reduce noise in your explicit analysis, and also with that increase the robustness. So that's all based on customer requests. Then the Matt 251 or Matt tailored properties is an interesting model if you're interested in taking manufacturing factors into account, for instance, from bake hardening processes before or something like that, because there you can define the yield stress as a function of strain and strain rate, so that's like Matt 24, but also two user-defined history variables, and that could be anything, hardness, hardening factor, or whatever. And yeah, in R13, this is now available in implicit analysis as well. Then we added two new options to Matt 224 GYS, generalized yield strength stress. So you can use this flexible Taylor-Quinic coefficient there, and also the log interpolation. And there is a new regularization option for the Diem. We already saw the Diem material model with this FLD criterion for solids. Another new feature there is now this parameter P5, where you can refer to a curve where you can define a regularization factor versus the element size. So it's similar to the LC-REG-D curve in Gizmo. So to deal with situation, or to reduce mesh sensitivity, so that you only need one material card for all kinds of different mesh sizes. Then that was also on Jason's slide. We have the possibility now to split up the internal energy that comes from the material models into elastic, plastic, and damage portions. And that is implemented for a number of material models and also the damage and failure models. And it should improve the understanding of structural behavior, for instance, energy consumption in crash parts as shown here. And yeah, as you can see, most of the energy goes into the plastic, is plastic and a little bit elastic. Then we have a new input format for tables, which is a kind of a replacement of the table 3D, table 4D that you already might know. So, and the keyword is called define table compact, and it allows a clearly arranged tabular input of data as shown here. So this is what's that? That's a 4D table. And it would look way more staggered, I would say, with the old approach. So you would have a table 4D with few table 3Ds and table 2Ds and curves. And that's all now put into one. And you have to take care of the syntax somehow, but then it could be interesting. Maybe it's not yet, I think, really supported in preprocessors, so that's kind of new, and we will see that. But we have a conversion tool from the old format to the new format, because all that is just done in the keyword reading phase, this transformation. So then we have some enhancements for cohesive elements and materials. So we are now supporting foam materials, which is done via the MATadd cohesive. So now you can use MAT5783 with cohesive elements. There is a special option for the deletion of neighboring elements, which is now supported for the MAT-Arup adhesive, and for the famous or popular material MAT240 for cohesive elements, we have added 2 new options, which is the functions and also a flexible exponent for the yield and damage initiation criterion. Then that's also new. If you want to model gaskets, we now have the possibility, and if you would like to do that, you have to combine this new material cohesive gasket 326 with the cohesive elements and this gasket T parameter on section solid. And the gasket T corresponds to the gasket thickness to represent the membrane behavior. And for the out-of-plane behavior, you can define these kind of loading and unloading curves. More enhancements for the connections. There is some velocity-dependent hardening and failure for MAT68. There is a new uniaxial option for MAT spot weld to deal with some stability issues. And there is also defined connection properties is now extended for new materials. I will skip that because I'm a little running out of time. Then for the pointwise connection of solids, we now have the possibility to use a SBR2 to do that. So that was a long time only working for shell elements, and now we extended to be able to connect solid elements, and that is also for SBR3 in the future or in the next release. And so that could be quite interesting if people go more and more using solid elements in Crash as well. Yeah, for batteries, Jason already mentioned all kinds of new features were added, maybe for the app use of batteries to be used in crash analysis. There is now only to mention one of them, there is this erosion capability now added to the BAT-MAC model. And with the removal of these elements, Rendell circuits are is removed, and also internal short resistance is switched on for the surrounding. For airbag particle, there are also all kinds of new features added. Just to mention that you can now include solid parts in the CPM airbag list. There is a new keyword option jet for airbag particle. And for vents, I think Jason already mentioned that this morning. There's also new developments. Sensors, we have a new keyword, sensor-defined update. And the idea is to define birth time, death time, and update frequency there, so that if you have a lot of sensors, then to reduce the CPU time with that. We have new options, M and M moment on sensor-defined force. We have new control entities on sensor control for electromagnetic solver, for constrained local, and for the sensor switch is also something new. And that could be an interesting new option, the so-called no-copy option to reduce CPU time. The idea is, or the problem is that the copying of history variables, for material history variables, was done not very efficiently. And so that was now, or is now totally avoided by keeping it in memory And that can reduce the element processing time by 5 to 25%. And in a full crash analysis, I would, if you use MAT24 a lot, Gizmo a lot, then it could reduce your total CPU time of a crash analysis by, I would say, 5 to 10%. So that's on control solution. And defined pressure tube, we have some new options there that I will not go into detail with. The idea was to handle some special situations better, like shocks and rarefaction waves. There's a new keyword load pyro actuator for applications like this. So that's a movie, and that's the same in LS-DYNA. Okay, and that's my last slide. So that's about the functional mockup interface. So if you want to run another program, another software at the same time with LS-DYNA, then you can do that, and you can find all kinds of informations here if you want to try. And there is examples, a manual, and so on. And so that brings me to the conclusion, where just to say there is way more in R13. That was, I picked just some items from the crash relevant topics. And you will find a more comprehensive list of enhancements in the release notes, and the manuals will be there soon as well. Thank you.
Thank you.